Well, now I'm recording.
Oh, we're all set together.
You got it?
You can do it.
She said no.
Oh,
All right, so number 12, we have y equals 2x squared, y equals 0. X equals 2. And it said the y-axis, what happens when I have to do y-axis or any vertical rotation? So what is x over here? Divide by 2 and then square root it, right? Everybody good with that? All right, so then I'm gonna actually flip back and forth. Not this one. What's wrong? Can you not find yours?
I found it.
Oh, good.
That's 74.
I'm the same way sometimes. 2x squared, y equals 0. X equals 2, and then it says the y-axis. So when we look at this and we're looking at this figure, try to erase everything like in your brain that is not in those boundaries. So anything on that left side is not going to be in those boundaries. Anything above that intersection. Does everybody understand that? So none of that graph really exists. So all you have is this little triangle part. Okay, so I'm going to go back. I'm going to try to explain this to you a little bit because some of you are having trouble with how to set it up from here. All right. So your R of Y is always your biggest radius. So wherever you're rotating, so in this case, we're rotating the y-axis, the furthest distance. Does everybody understand that? This would be your big R of Y. Your little R of Y is going to be the thing that's closest. So you can even think about it as on this one, it has to be left and right. Okay, the furthest one away is on, yes, the furthest one away is on the right. So that's over here. And the closest one is this one. Does that make sense? Okay, so the closest to the axis. So what we're going to do is for big R of X, I'm sorry, not R of X, R of Y. I'll do that every single time, so I apologize. If you're writing in pen, just give it a minute. The biggest R of Y is going to be your furthest distance. How far is it from here to here? Remember, this line is X equals 2. 2, that's it. Everybody see that? So one more time, your distance from the y-axis to this furthest function is 2. Sorry, I should write as little r. Little r of y is going to be from the y-axis to your littlest function or your closest function. So what is your closest function? Square root y over 2. Now, this one looks like this and you're not subtracting. So if you went ahead and you guys remember, we talked about, some of you come ask me questions. If there's a gap, this one is not washer method. This one is not washer. Everybody understand that? There's no gap. So there shouldn't be any subtraction within your R's. If you have a gap, there will most likely be subtraction. Okay. So one more time, this is disk method. Why do we have to have 2 functions on disk method? Because when we rotate it and we make this solid figure, this part is a whole. So we got to get that out. Does everybody understand? All right. So then your normal equation. Do I have my A and my B? Mhm. How did I get that? Yeah, you can also look at the graph and see how far it stretches on the y-axis, because we're talking about the y-axis. So what is this point up here? It's going to be 8. Everybody got it? All right. So big R of y squared minus little r of y squared. And we're going to do y. What is 2 squared? Square root of y over 2 squared. Integrate it. Four y. What's the next one? Y squared over 4. Sorry, minus. Everybody okay with the y squared over 4? If we take this over here, just so you can see it. Remember, it's 2 the second over 2, but we already had a 2 down there. So that's why it's y squared over 4. So just so you can see that. We're going from 0 to 8. You're going to do 4 times 8 minus 8 squared over 4. Minus your zeros don't matter, but I'm going to write them down anyway. Eight times 4, 32. 8 squared is 64. Again, you can do this all in your calculator. You can do it by hand. It doesn't matter. What is 64 over 4? What is 32 minus 16? There you go. Again, the hardest part is figuring out what big R and little r are. Once you finish that, you guys are good to go. So then now we have 12C. What does 12C tell you? I didn't write it down and I don't want to overlook it. Too lazy. Y equals 8 is what I needed. Rotate, revolve. Y equals 8. Okay. All right, so in this case, everybody see the green line? So that green line is where we're rotating. So think about flipping that thing over here. It's kind of the same thing, except for you're flipping it over a horizontal instead of a vertical. So we're going to keep it in terms of X. So I'm going to redraw this for you guys so you can see it. So this is what we're rotating around. Okay. We still have y equals 2x squared, y equals 0, and x equals 2. All of that is still the same, right? Our big R of x, the distance from your axis of rotation or your line of rotation to the furthest function, which is all the way down here. How far is that? From here to here. 8. That's it. Little r of x, I told you again, is the distance from your line to your littlest function. Which one is that? Which one is your littlest one, or the one that's closest to your axis of revolution? Right, it's not the 0 because that's the one we used for the first one. So the 2x squared. It is the distance from that line to the function. That's how you find the radius. It is this exact way every single time. Okay, how far on the big one and how far on the little one. Now, if you have two different curves, so like this was a curve instead of a straight line or a horizontal, then you guys would just keep subtracting whatever the functions are. This one just happened to be 8 minus 0 because our bottom function is y equals 0. Does everybody understand why we didn't subtract there? You good? All right, so then just normal, everything else is fine. What are my values? How'd you get 0 to 2? You can plug it in, or you have x equals 2 right here, so you knew that was it. It's how far it stretches on the x-axis. So if I can grab it in my calculator, I can see that it goes from 0 to 2. And then big R squared minus little r squared dx. Some of you are not multiplying this correctly, and I'm gonna blame myself just a little bit because I tried to make it quicker for you and do this, do this, do this. But if you need to write it out, get your separate sheet of paper, write it out real quick, make it real sloppy, whatever, it doesn't matter. When I multiply it out, I get 64 negative 16x squared, negative 16x squared, and 4x to the 4. Remember, when we put these together, all we do is add the numbers. And we get this. Okay. I always just do it to the side. Like my whole, and if you think I'm like seriously, like this is my work, I do all kinds of stuff over here in the side margin, away from all the other stuff I do. So I do use a lot of paper, but at the same time, I do have all my work over there to look at. So if I go back and I'm like, where'd I screw up? I at least have my work there. Okay. So this one, 8 squared is what? 64. What do I have to do right here? Distribute that negative to all of this. So what am I going to have? Minus 64. Everybody good with that? What happens? Uh, 32x squared minus 4x to the 4th dx. And then I can integrate. Actually, I don't want to integrate here. What can I do? A what? A 4, right? Don't pull out the x's. Remember, we don't ever have x's out here. We want to integrate the x. I can pull out constants, right? So I'm gonna pull out that 4. Not this, yes, this. 0 to 2 of 8x squared minus x to the 4th dx. So now 4 pi times, integrate the other ones. 8x to the 3rd over 3, keep going. From 0 to 2, leave that 4 pi out for a minute. Remember, we don't have to do the 0. We're going to do the 2. This gives us 64 over 3. 2 cubed is 8 times 8 is 64 over 3. 2 to the 5th is 32 over 5. I just went ahead and did it in my calculator, but you would have to get a common denominator if you were doing it by hand. What's your common denominator? 15. So cross multiply, multiply on the bottom. When you finish, when you multiply or when you subtract these and then multiply by 4, you get 896. Sorry, dyslexic there for a minute. 896 over 15. 64 over 3 minus 32 over 5 times 4, 896 over 15. Very good. Any questions? What you laughing at? Maybe you think funny. Very good.
So did you actually put stars with you?
Yes.
Like a lot.
That's what it said.
My grandma said 3. Why are you reading?
1 to 2 is what I've heard.
No, she's crazy.
But I literally just went over that when I explained to you that I was passing out papers because we were gonna get snow and it could possibly 1 to 2 inches and who knows how long we'll be out for that, but I planned for a week.
My brain is. Cry.
And then we talked about the test. If it was here, then
Oh,
you
I
would
heard
get,
that's why we all have different versions. Yeah.
if it's online. I might do it if it's not online. Who knows? All right, 12D. What does 12D say? What was it? Y equals 2x squared and x equals 2, and we're revolving around. X equals what? 2. Well, I wrote that on most of them, but I didn't. on these. Okay. All right. So x equals 2 is what kind of line? It's a vertical, so I need to put everything in terms of. Mhm. So what do I need to do to my function? We already did that, so we don't have to. We don't have to do the extra work for it. We already know. All right, same function. That looks like this. But now we're revolving here. If I revolve it, is there going to be a hole? So if it's touching the line, that's where that 0 happens. Remember on the last one that we had that did the x-axis, we were touching that 0 anyway. Is everybody good? All right, so your big R of x is this distance. Did I even draw it? I didn't draw it. Sorry. This. Make all these. So your 0 here, your big R of x is going to be what you're revolving minus your function. Again, little r of x is 0. And why did I tell you it's 0? There's no hole, so there's no washer method. Okay, no hole. Do y'all understand what I mean by that? Are you sure? Does anybody not understand about the hole? Okay. I'll be asking in a minute. All right. Volume equals. Where are we going from? Say it again. 0 to 8. Your big R. 2 minus square root y over 2 squared. And then I'm going to go ahead and put the 0 squared just so you can see it, but you don't have to put it over. All right. What do I need to do? Okay. So remember when you square it, we're going to write it twice. Two times 2 is 4. 2 times the square root of y over 2. Don't make it too hard. Is 2 times the square root of y over 2. And then we're going to have another one. When we do it here. And then on the end, what happens when I multiply the square root times the square root? It'll just be y over 2. Perfect. So when I finish it up, 4 minus 4 square root y over 2 plus y over 2. So our volume from 0 to 8 of 4 minus 4 square root y over 2 plus y over 2 dy. All right, Andrew. Do the easy one. Remember that this 4 is a constant, right? Yes. How can I fix this? I don't even like the way it looks. So this is the problem on this one. Did anybody fix it? Yes, no, maybe. You can. Don't do anything yet. Don't write anything down. Let me see if that will actually work, because that is not how I did it. Okay, so let me see if it just works. So he said, make y over 2 to the 1/2 power. So what would I do? Yeah, it's not gonna work that way. Here's why. The y can stay the 1/2 power, but the 2 cannot. You see what I'm saying? Because that gives you this is what I did, okay? So the problem is that square root on the bottom. Do you remember how to get that square root out of the bottom? So that gives us 4 square root of 2 over 2 y to the 1/2. What happens now? Which just gives you 2 square root of 2 times y to the 1/2. Now integrate that. I know it sounds crazy. Do we have to integrate 2 square root of 2? No. But I need to integrate y to the 1/2. What is that? Y to the 3/2 over 3/2. But do we divide fractions? What do we do? So if I flip it, it's 2/3, right? So what am I going to have right here? Don't make it complicated. Look at this. 4 square root 2 over 3, right? So minus 4 square root 2 over 3. And what about my y? To the what? 3/2. That's perfect. So that's a rough one. Okay. Is that right good? But do you know how to do it? Yeah, it just takes a little more work and you just have to be reminded, oh yeah, I got to do that. I'm sorry. Why did you do it?
She told you
Because I
not
had
to do
a
your homework.
tutoring appointment.
I got you. I'm with you.
Yeah.
Don't.
I'm sorry, just got the class started attacking me when I said I was like doing my homework.
We thought you just didn't hear me say. That's all. We were concerned for
I
you.
was just working on it.
We weren't attacking you. It was genuine concern. Sometimes when people get help, they feel attacked. It's okay. It's okay.
Oh, yeah.
Y'all ever watch like Intervention?
No, I made you should.
They try to get them people help. All right, let's finish this up. Let's finish this up. Integrate y over 2. Integrate y over 2. What? What? Sorry. I don't even think I did that one right. Okay, keep going. What do I do now? What? Put in your 8 and your 0. I'm too lazy, so we're gonna see what it is. All right, so 4x minus alpha y equals 4 square root 2 over 3x to the 3/2 plus x squared over 4. And then we're plugging in 8. So we get 5.3333. What is 5.333? Essentially, it's what? I'm gonna go, sorry. You can go ahead and put in your 0 if you want to. No, it's gonna be 0. 5 1/3. So 5 plus 1/3 gives us what? 16/3. So our final answer is 16/3. Everybody good? Yes, no, maybe? All right, 13. 13 gives you y equals x squared, y equals 4x minus x squared. And A wants you to do an x-axis rotation. Stop it. What's wrong?
Oh, we've been doing 12 the whole time.
I was told
We've been- Those 12. then what? Oh, I see. Oh. Huh? Well, I was kind of, I guess in my brain, I just go in 12, 13, and normal 15 more.
Not like you said, 12A.
All right, so here's your function. I don't like that. Why are they the same color? They're not the same color, but they look the same color. Yeah, I don't like that. That's better. Okay. So when we're looking at these two, we're revolving around the x-axis or rotating the x-axis, whatever you want to say. And we're just looking at that little like football shape or whatever. I know it's not a football shape, but y'all know what I mean, the ellipse. So what do we got to do? How are we going to do this one? Say it again. Mhm. What else? So she said it's going to be this method. It's going to be like this method. What else? What else do we need to know? What are the 4 things we need to know? Okay, so what is A and B? 0 and 2. How do we know it's 0 and 2? Yeah, on the x-axis it goes from 0 to 2. Is everybody okay with that? How would I know otherwise? Like I can't use my calculator, I can't graph it, set them equal to each other. Okay. What? So your coordinate right here, where they cross is 2, 4. So your x value is 2. Yep, so the distance that they stretch is from 0 to 2 on the x-axis. Got it? So if we were looking at y-axis, we turn it the other way. Look how far on the y. So if we decided to rotate this one on the y-axis, what would we use? 0 to 4. 0 to 4. Does everybody see that? Because that's how far it is on the y-axis. Okay, so 0 to 2, that's our A and B. Why are you doing R of X? Big R of X is 4x minus 4 minus whatever I said. Because it's on top. Does everybody understand? So you might want to think more left, right, top, bottom. Okay. So which one is furthest from the axis that we're rotating? The red or the black? The red, right? Which one is that? It's going to be the negative function. Is everybody good? That's why that one goes first. Your little one is going to be the one that's closest to it. So the closest one is the black one, and that one would be the x squared. So that's what we're going to do. So our big R of X, you said was the negative one. And our little R of X is going to be the positive one. All right. Finding the volume. Just to reiterate, 7.1 was area. What's the difference in the area and the volume? pi, pi. They're just subtracting and then pi. Everybody got it? We're gonna go over those when we do our review, but I just wanted to remind you. They're really easy. So the first part of your review and the first part of your test is basically just the integration and plug it in. It's not like trying to figure out which function is which or anything like that. All right. So you said 0 to 2. Our first function. And then our second function. If you need to multiply that out, go ahead and do it. Like I said, you can throw it over to the side. I don't care. What's the first term going to be? 16 x squared. 4x times negative x squared. Thank you. Negative 4x cubed. The middle one is going to be the same. And then negative x squared times negative x squared. Positive x to the fourth, which gives you 16x squared minus 8x to the third plus x to the fourth. So I'm going to go ahead and write that there. What's going to happen right here? Say it again. Negative x to the fourth dx. What happens? You guys don't have to rewrite it. You can just integrate from here. But what can I do before integration? I can. Do you have to? No. So on the last one, we took out that 4. This one, you don't have to. Why did you take out 4? The numbers are really big. It doesn't matter. So if you forget, I'm going to show you that it doesn't matter. So integrate 16x squared. What do I get? 8x cubed turns into, which actually turns into 2x to the fourth from 0 to 8. I mean, 0 to 2. So pi times 16 times 2 to the third over 3 minus 2 times 2 to the fourth. And when you plug that into your calculator, you keep getting off 32 over 3. It'll be 128 over 3 minus 32. Any questions? Everybody good? Guys, realize we're finding the volume, so if you come up with a negative number, you did something wrong. Chances are you did it backwards or you multiplied wrong. Got it? All right, 13A, 13B. Sierra, we're still on 13.
I got it this time.
Because 14.
I put B down already.
It's still x squared and 4x minus x squared, right?
Yeah.
All right. So now we're going to rotate over this red line here. What do you notice? See how there's a gap between the function, the two intersection functions, that little football, and the line that we're revolving? Does everybody see that gap? That's the hole that I'm talking about. So anytime it doesn't touch the axis, you're going to have to do some subtraction. Does everybody understand that? All right. So the first thing that you're going to do, I'm going to kind of redraw it again for you. Like this. Okay, this is what we're rotating. We need to figure out our R of X. How do we do that? Remember that your top function is your negative and your bottom function is your positive. Which one is the furthest from the line? The bottom one, which was Remember, they look like this. That's what's causing that football shape. Which one is the bottom one? Which one makes a U shape? X squared, that's the one. And then you have to subtract it from the line you're rotating from. So big R of X is going to be 6 minus X squared. Why did we pick X squared? It is the furthest from our axis of rotation. Okay. What about little r? Say it again. But we still have to subtract it, right? Because there's that gap. So 6 minus, make sure you put parentheses, 4x minus x squared. So again, if there's that gap, you're coming from that function down.
So 6 minus X.
Okay, so when we're looking at this function, and it looks like this little football shape or whatever, and we're rotating here. We want the furthest distance to be our big R. We want the littlest distance to be our little r. This is the x squared function. So that's why we use x squared, because it's on the bottom. It's the furthest away. And then we use this one, this 4x minus x squared, because it's the closest to our axis of revolution. So it'll be our smallest r.
So 6 minus that.
Because we have a gap. Because we have a gap.
Yeah.
Yep. So we're going from there. All right. So volume equals from where to where? Still working in terms of x, right? Still working on the x-axis. So what does this graph stretch on the x-axis? 0 to 2, still 0 to 2. To your big R squared. I'm going to fix this though to be 6 minus 4x plus x squared. Squared. That one's a really crappy one because you have to square a trinomial. All right. We're going to work this one first. Multiply the first two. What do you get? 6 times negative x squared is negative 6x squared. You'll have another one of those. And then a positive x to the fourth, making this 36 minus 12x squared plus x to the fourth. Very good. Okay. Now we got to multiply the other one. 6 minus 4x plus x squared. 6 minus 4x plus x squared. 6 times 6.
36.
6 times negative 4x. Mhm. 6 times x squared. 6x squared. Then do your middle one, negative 4 times, or sorry, negative 4x times 6. I just put them in order, like I lined them up so I don't have to find them later. Okay. Negative 4x times negative 4x. 16x squared. Negative 4x times x squared. There you go. Sorry, to the third. And then the last one, x squared times 6. X squared times negative 4x. And then x squared times x squared. So this, when you add it up, gives you 36 minus 48x. 16 plus 6 plus 6. Yes. Minus 8x cubed plus x to the fourth. Remember that we're taking this function and we're subtracting this one. Does everybody understand that? So what we have now, 36 minus 12x squared plus x to the fourth, your first function, minus 36 plus 48x minus 28x squared plus 8x to the third minus x to the fourth dx. Tell me what happens. Here's your square terms, negative 12 minus 28. So those are done. I have a singular 48x and a singular 8x to the third. Does it matter that I put them in like a weird order? No, not at all. Integrate it. Or since they're big numbers, what could I do? So this one, I'm gonna take the number out. I'm gonna take out an 8. So again, all that does is makes your integration just a little bit smaller. That's it. So negative 5x squared plus 6x plus x to the third. Integrate negative 5x squared plus, which actually turns into 3x squared, and then from 0 to 2. When you finish this out and you plug in your 2, it's going to give you 8 pi times 8 over 3, which gives you 64 pi over 3. Okay. After I did that one, I tried not to give you any more that were that intense. Like this much work. That's too much. You know how to do it. It's easy work, so I don't have to worry about that. All right, check this next one out. We get y equals x, y equals 3, x equals 0, and y equals 4. Now realize on your AP exam, you're not getting Desmos. So the only thing your calculator won't do is any of your x's, but what is x equals 0? It's not the x-axis, the y-axis. So you can do these on your calculator. That's fine. 3, x equals 0, y equals 4. And graph it and understand that x equals 0 is the y-axis. All right, so what shape are we rotating? The triangle, and we're rotating about y equals 4, right? Yes, okay. So what we have is a triangle that looks like this. And then we're rotating here. Now let's look at this triangle one more time. What is it? What is it made up of? What is this right here? This horizontal line. 3, right? Okay. And then this function is y equals x. All right. And this is 4.
How did you, where's the y equals 4?
That's what we're rotating. It told you in the directions. Correct? Am I right? If I can remember back. Okay. So in like the bold-faced directions before you get to the actual problem. What? But he didn't know where it came from. Why did I write it down? He was just looking at 15. Yeah. Yeah, no. Yeah, so they leave it in the directions for the whole set of problems. All right, so what's happening in this? Tell me what's going on. Okay, great, good answers. There is a hole. How do you know there's a hole? There's a gap from where to where?
Axis to
like
the
3 to 4, right? From the triangle 3 to 4. Okay, so what does that mean I'm gonna have to do? I'm gonna have some subtraction in my R of X's, right? Okay. So how do I figure out which one is big R of X and which one is little R of X? Which one is the furthest away? Okay, look at y'all. So what is my big R of X?
4 minus X.
Why is it 4 minus X? Good. Oh, sorry, I'm trying to do the integration already. 4 minus X. What is little R of X? 4 minus what? 3, which is 1. Perfect. Everybody starting to understand? Remember I told you yesterday, once you do a few more, it'll start clicking and understand. That's why I wanted to do it with you. All right, so then do your formula. Nope, about forgot my pi. Ooh, what are my values? 0 to 3. How'd we get 3? Did it not tell you that it went up to 3? Okay. What do we do now? Also, what is this coordinate right here? Think about it. If y equals x, 3, 3. So you couldn't screw it up. Does everybody understand that? If you pick the x or the y, you couldn't screw it up. 0 to 3 of 4 minus x squared minus 1 squared. All right. If I multiply out 4 minus x squared, I get 16 minus 8x plus x squared, right? 4, yep, minus 1. So what am I actually integrating? (15 minus 8x plus x squared dx). When I integrate that, I get 15x. 8x squared over 2 reduces to 4x squared, and then x cubed over 3 from 0 to 3. Don't have to plug in the 0, just plug in the 3, and I get 18. So our final answer is 18. So again, the hardest part about these is figuring out what your big R and your little r is. So hopefully you're starting to get that a little more. Any questions on 15? It's close. It's almost time. Then we had 18. And we had y, if you can't see it, I'll move it in just a second. Secant x, y equals 0. The good thing about these is they typically give you your values. Problem is, what is secant? On Desmos, I can type that in. I can just type it in as secant. What is secant though? It is 1 over cosine, so if you need to write that down, that would be how you put it in your regular calculator. Y equals 0. And then I don't need to do anymore. Some 0 to pi. Let's see if I can do it. I'm gonna see if this works. I don't ever do this. 0 less than or equal to x less than or equal to over 3. So that little section right there. That's good. That's good. All right. And did it tell us what we were rotating? I didn't pay attention. Y equals 4. So I'm gonna throw that one back on there too. I didn't know if this was still in this section or the next one. All right. What is y equals 0? What the x-axis. So we're actually this little shape down here. You guys see that? This little shape down here. So ignore the fact that this is shaded. It's actually this bottom part right here. All right. So if we're rotating this line, which one is the furthest away? Y equals 0. How far away is it? 4. Is everybody good? So your big R of x is going to be 4. Now we can go back to the other one. So your big R of x is gonna be 4. What about your little arc of x? And remember, you got this by doing 4 minus the function 0 was the lowest or the bottom function. So you would do 4 minus the top function, which is secant x, just like we've been doing. Okay. Volume. Ooh, from where to where? Yep, because they gave us that. Of 4 squared minus 4 minus secant x squared dx. Don't stress out. I'm gonna help you out. Okay. 0 to pi over 3 of 16. And then what's this gonna be? Not minus that. Plus secant squared x. But then I'm subtracting it all. So subtract 16 plus 8 secant x minus secant squared x. This one is actually fairly easy because if you go back to your integration rules in your book, so if you've got your book open, go back to your integration rules in the very front. Or don't. I love y'all, I promise. What's your integration of secant? It's literally in the very, very front, right there, integration of secant. Good job. Way to break your book.
It was like this whenever I got it.
Sure.
It was.
Mm.
Does it say
Are you doing integration? Integration is that little squiggly line. It's on the very front page. LN, absolute value, secant tangent, right? Okay. So we have 8. Guys, this is a formula. So the integration of secant u is ln secant u plus tan u. That's in the front of your book. Sorry, you can't see anything I wrote at all. So we have 8 secant x. So we're going to pull that 8 out because it's a constant. Ln secant x plus tan x. And then again, in the front of your book, secant squared x. You don't even have to change it. There's already a function for that. The integration of secant squared x is tan x. So minus tan x from 0 to pi over 3. And then we plug it in and you guys can remember what is secant. So you can plug this straight into your calculator 1 over cosine. You get pi times, when you plug all this in, 8.8036. And then when it looks like this, you can put it together if you want to, but typically if it's rounded, they'll just go ahead and do your decimal answer, 27.66. Let's go ahead and do 19 because it's easy. And then you will have the rest for homework. Y equals x, y equals 0, y equals 4, x equals 5. X equals 5 is where we're rotating. So if I go back over here, this can go. Y equals x. Yeah, what's wrong? Say what? Yeah, it happens. All right, y equals x, y equals 0, y equals 4. So y equals x is this red line. Y equals 0, where is that? The x-axis. And y equals 4 is this one up here. So you guys see that you're rotating like this little trapezoid. We're rotating it over the blue line. What do you notice? So There's no hole, right? So there's no hole. So let's go back here. Not R of X. I told you I do that every time. It's gonna be R of Y. And little R of Y. Let's go back to our graph. Which function is the furthest from this blue line? And when we talk about a vertical line, we're talking left to right. So all the way over, what's the furthest? Y equals X. Everybody good? What's the closest? Since we have no hole, what are we gonna have? 0, right? Does everybody understand that? No hole, it's gonna be that 0 because there's no gap, no nothing like that. All right, so R of Y is gonna be our rotation minus, but we're doing a vertical, so we gotta make it in terms of X equals, it already is that way. So just make sure that you're subtracting 1. Okay, if you need to rewrite it so that you can understand, we had to solve our equation for X, it still gives us Y. So again, because we're right on that, we have a 0 here. All right. Go back and look at this thing. Go back and look at this thing. We're rotating vertically, which means we're talking about Y. So what's our height? 0 to 4. That's what we're using for our A and B. I don't know what I just clicked. Something comes up. I'm sorry. 0 to 4 of 5 minus Y squared dy. Multiply it out real quick. 25. Oh my God, multiply them together. The negative 5y times 2 is negative 10y. Square the last one. Yeah, we got it. Y squared. It's okay. It's all good. It's all good. I didn't put my pi up here. Sorry about that. Yeah. So pi integrate. We get 25y minus 5y squared, 10y squared over 2 would be 5y squared. Plus y to the third over 3 from 0 to 4. Your 0 will not matter. And when you plug in your 4, you get 64 over 3. The only one that's easy, that I see you having any trouble with is 29, and not because it's a hard problem, because you have to multiply trinomial. That's it. Okay, so all the rest of them are pretty cut and dry. Use Desmos if you need to, but you literally only have a couple problems left.